class. This is Mr. Sifuna. I want to discuss about Newton's laws of motion. But before we talk about Newton's laws of motion, I want us to think about some of the everyday experiences that we go through. Sometimes, like as we are approaching the KCSE exam, it becomes very difficult for some of us to revise, to read. So unless we use some mechanism to enable you read or encourage you to read, you'll find that some of us will remain there. So many public schools, as at now, as I speak, students are just sitting at home. They are just there like that. They are waiting for the teachers to remind them when schools may resume for them to start. So they are in a state of resting. They are just resting at home there, while others are doing some work. Like, appreciate what your director has done. You are at least continuing. So when we are talking about the Newton's laws of motion, that means there must be something to do with motion, or if there is no motion, then that object is at rest. So for us to understand the laws of motion, think of an object which is resting. Then, after thinking about an object which is resting, now think about an object which is moving. So the guidelines on how the object is going to behave while it's moving or when it was at rest is what we refer to as the Newton's laws of motion. Let's watch this short clip, which is talking about Newton's first law of motion.
Newton's first law of motion. In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever, or after some time would naturally stop moving? The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. To understand Newton's first law, in our everyday life, we observe that...
I want you to observe that part of the ball. How is the ball going to move when the force is applied to it? Is it going to move in a straight line? Or is it going to curve? How is it going to move?
Effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever, or after some time would naturally stop moving?
The ball naturally stops moving. It does not continue moving forever. So there is some external force. And I know in Form 1 you talked about types of forces. So there is a force which opposes that motion. That's the external force we are talking about. And that is frictional force. But the ball, how was it moving? It continued moving in a straight line. So that's a key point. The ball was at first at rest. So it continued remaining in that state of rest until when it was kicked. So there was an external force which changed the state of the ball from rest. Then it started moving. And when the ball was moving, it moved in a straight line. Then it stopped. Why did it stop? There was an external force, which we refer to as frictional force.
The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force.
Unbalanced external force. So the other term for unbalanced external force, we also refer to it as resultant external force. So a body will continues to be in its state of rest. So when you are stating this law, don't start by talking about uniform motion. Start by talking about rest. So rest comes first, then motion comes later. So our body continues to be in its state of rest or of uniform motion. At this part of uniform motion, I want you to add a statement in a straight line. State of rest or of uniform motion in a straight line, unless acted upon by an external force. Okay. So I want to continue
Understand
playing.
Newton's first law, you need to understand what unbalanced force is. If you have seen a game of tug of war, you would have seen two teams pulling a rope in opposite directions. If the rope doesn't move, the forces applied by the teams are balanced forces as they are of equal magnitude in opposite direction. If one of the team applies greater force, it pulls the other team and the rope towards their side. In this case, the forces are unbalanced as the two forces are of unequal magnitudes in the opposite directions. If one of the team lets go of the rope, the opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest, it tends to remain at rest, and if it is in motion, the opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest,
you see that ball will keep on dropping vertically downwards. That means it continues remaining at rest.
It tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion.
So when an object tends to remain at rest, that is inertia. When an object tends to move in a given direction, that's inertia. When an object continues to move and it doesn't want to stop moving, that is inertia. So there are three categories of inertia: inertia of rest, inertia of direction, then inertia of motion. To clarify the meaning of the term inertia, this is the tendency of a body to remain in a state of rest or of uniform motion. So when an object tends to remain in a state of rest or in a state of uniform motion, then we say that is inertia. So as I was just giving you an example of some of our students, some may just want to remain without revising, although that's not a very good example related to that. You see, when an object tends to not to change from one aspect to another, of course here we are only talking about two states, not the states of matter, but the states of an object in motion. There are only two. The object is either at rest or it is in motion. And if there is an external force, it will change direction. So that's why we are talking about inertia, the tendency of a body to resist the change of state from rest to motion or from motion to rest. But there are those three kinds of inertia.
Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is a term. Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, The movement pushes the passenger back.
So this lower part is at rest. No, the bus starts moving. The lower part is in contact with the floor of the bus. So the feet and the bus start moving, but the upper part continues being at rest. So the person will jerk backwards.
Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is the tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of shock brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body.
Now, my good students, I want you to understand very clearly, you don't just talk about inertia, but I want you to remember we are talking about three kinds of inertia. Inertia is the tendency of a body to resist change. So we have inertia of rest, we have inertia of direction, and we have inertia of motion. You see the inertia of direction, you have been given an example of a car which is negotiating a corner or a bend. You'll find that when it turns to the right, you are thrown to the left. When the car turns to the left, you are thrown to the left. That's inertia of direction. You want to continue moving in that particular direction. So when you are answering questions to do with inertia, don't just say it is due to inertia. You have to specify. If the car was moving, then it stops suddenly, you will be jerked forwards. That means your body tends to continue moving. So that's due to inertia of motion. But in the first case, when the car was at rest, then the bus suddenly started moving, the lower part of the body moved with the bus, but the upper part remained at rest. We refer to that as inertia of rest. So the three types of inertia, you should be able to remember them: inertia of rest, inertia of motion, and the inertia of direction. I know most of you can be very good drivers. I know students at Form 4, most of them, they know how to drive. When you stop a car, when a car is moving, then you stop it, you are thrown forwards. That's inertia of motion. When the car is at rest, then you start it, suddenly you are thrown backwards. That's inertia of rest. Then when you go around a roundabout or a bend at a higher speed, the body is thrown in the opposite direction. That's inertia of direction. It's very important for us to know that.
When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in the state of motion due to the inertia of motion causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is a tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia.
Yes. Newton's first law is also known as the law of inertia. You can be asked to give the meaning of the term, state the law of inertia. So when they ask you to state the law of inertia, you state Newton's first law of motion, which I want to repeat. It states that an object always remains at rest or in uniform motion in a straight line unless an external resultant force acts. A body will always remain at rest or in uniform motion unless an external force acts. Now, I want us to clearly get those points. Let me maybe put on the earphones for you to hear me clearly. Abdul Hamid, how are you? Okay, hello, Abdul Hamid. Are you hearing me?
Hello, sir. Yes, sir. I'm hearing you.
You're hearing me? That's good.
Yes.
Okay, Abdullah Ali, how are you? You are hearing me?
Yes.
Good. John, hi. How are you, John?
Hearing you.
You are hearing me? John, are you hearing me? Please just get back to me. Okay. Abdul Malik, Abdi Malik, how are you? Are you hearing me, Abdi Malik?
Yes, sir.
Abdi Shakur?
Yes, mwalimu nakusikia.
Alafu sauti ya video mnasikia vizuri?
Yes, yes, ma'am.
Okay, that's okay now. Thank you for that alert. So, Newton's first law. The key points I want you to know about Newton's first law are as follows. Now, the first thing, state the law. That should be the first thing. The second thing, you must know what we call inertia. Then, of course, under inertia, three forms of inertia. You must give some everyday examples of inertia. Then at the end, we must be able to define force. So when it comes to Newton's first law of motion, these are the key areas I want you to understand. By the time we finish talking about Newton's first law of motion, you should be able to state the law. You should be able to remember the three, you should be able to give the meaning of inertia and give the three forms of inertia. Then we should be able to give everyday examples of inertia. Then we should be able to define force. What is force? In line with Newton's first law of motion. Now, if I may just show a diagram here, drawing a diagram here, then I'll ask a question about it. I want to have a mass suspended there. That mass is suspended using a string. And then the string has another, there's another string on the lower end. So I'll call this part, I'll also name this part. So this one, let's call it A. That is string A. And this one, we call it string B. Now look at it. Just as an emphasis on inertia, I want us to look at this. This is a common question in the exam. There is string A and there is string B. Now, when string B is pulled down, you see, when we now pull this lower end, the string is pulled down slowly. Something will happen. Either string B will cut or string A will cut. Then when we repeat the experiment, then it is pulled down suddenly. Yes. So these two aspects, I want you to understand. String B is pulled down slowly at first, then it is pulled down suddenly. All this is talking about Newton's first law, and it's emphasizing inertia. So when you pull down this string slowly, there is the weight of this object. The weight will be acting downwards. So this upper string will experience a higher force. There will be higher tension up here. So as you are pulling here, you have applied a force on string B, and this weight is also acting on string A. So string A is experiencing two forces: this weight of the object and the pulling force. So you are pulling down slowly. String B, as you are pulling down slowly, will only experience the pulling force. So I want you to understand that when you pull down this string B slowly, string A will cut. String B will not cut. It is string A which will cut. Why? String A is experiencing higher tension than string B. And the tension experienced by string A is caused by the pulling force plus the weight of this object. So A will cut. But now let's look at inertia. Supposing this string B is pulled down suddenly. If it is pulled down suddenly, that's faster. String A will not cut. It is string B that will cut. Now, I want to explain the reason as to why string B will cut. This mass here tends to resist the change of state from rest to motion. So when you pull this string B down very fast, it is string B which will cut, string A will not cut. The reason being, I repeat, the mass, due to inertia, the mass tends to resist the change of state from rest to motion. So the mass does not accept, it doesn't want to be pulled down. So when the mass resists to change from rest and start moving, because it has resisted, so string B will cut. Please remember the explanation I've given. If the pulling force is slowly done, you apply a force on B, you pull it down slowly, string A will cut because it experiences higher tension caused by the weight of the object and the pulling force. But when you pull down string B suddenly, that's very fast, it is string B that will cut. Why does it cut? Due to the inertia of rest by the mass. So the mass tends to resist the change of state from rest to motion, and therefore string B cuts. I would like you to sketch this diagram in your notebook. Indicate these strings, indicate these two aspects, pull down suddenly and pull down slowly. Then we put the short statement. Yeah, so if such a question happens to come in the exam, those are the reasons that you give. If it's pulled down slowly or if it's pulled down suddenly. Let me share you another aspect of the video we just maybe finished. We have not finished watching it. So another thing I want us to know is definition for force. Okay, now this is the time we can now interact as a class. I want to pose a question. basing on the video that we have watched and what we have discussed. What is force? Abdushakur, from what we have discussed and from the video, according to you, what is force? It's an open session, we just talk.
Sifuna,
Yes.
I see there is a student who has raised their hand.
Oh, okay, they should be unmuting. When they raise the hand and unmute, I'll be able to see. Try to answer.
I've allowed them to unmute themselves.
Okay, now that student can now answer the question.
Yes, Abdul Hamid.
Yes.
A force is a push or pull.
A force is a push or a pull.
Pull.
Okay, according to Abdul Hamid, a force is a push or a pull. Any other person?
Yes, Abdushakur.
A pull or a push of the object.
A pull or a push on an object. So we are all sticking to the Form 1 definition of a force. Now, you see, we have stated Newton's first law, and it's clearly telling us that an object will always remain at rest or in uniform motion in a straight line unless an unbalanced force, an unbalanced external force acts. So this is telling us something, that if this object is at rest, it will be at rest unless there is an external force. And if this object is in motion, it will continue moving unless there is an external force. So from that, I want us to reason in that line to define force. A push or a pull, it's okay, it's right, but according to Newton's first law of motion. Somebody else to try. Kasim? Yes. What do you think, according to Newton's first law, what do you think is a force is?
I think when a body is applied on a force, it will move from the rest. That's the law of first motion.
Okay, you have tried. You have said that when a force is applied to an object at rest, it will start moving. Okay, now what happens? Kasim, I'm still with you. Don't mute yourself. Kasim, I'm still talking to you. Now, you have told us that when a body is at rest, a force will make it to move. Very good. What if it's moving and you apply a force in the opposite direction?
When a body is moving, when it's applied on a force, it will stop because of that force.
Very good. Now, I want all of us to know that a force is that which can change the state of rest of a body or the state of uniform motion of a body. So you see, if there is a body is at rest, a force can make it to move. And if a body is moving, a force can stop it from moving. And a force can also change the direction. So according to Newton's first law, a force is that which can change the state of rest or of uniform motion of a body. I'm just writing for you. That is the meaning of a force according to Newton's first law of motion. That which can change the state of rest or uniform motion of a body is what we call force. In Form 1, you defined force as a push or a pull on an object. But according to Newton's first law of motion, we can't say it's a push or a pull. It is that which can change the state of rest or of uniform motion of a body. That's what we call a force. Now, when an object is in motion, it has a quantity which I'm defining here. Now, let's assume an object was at rest. Now it has a force, an external force has acted on that object. Then the object starts moving. That object possesses a quantity which is known as momentum. Any object in motion has momentum. An object at rest has zero momentum. So this momentum, we are looking at the mass of the object, and we are looking at the speed or the velocity of the object. Now, we are linking Newton's first law of motion to Newton's second law of motion. So for us to link it, we start by talking about the body is at rest. Then now from rest, the body starts moving because of an external force. It has caused it to move. So when this object is moving, we say it has momentum. Momentum is the product of force, is the product of mass and velocity. So these are just short notes. The product of mass and velocity is what we call momentum. So it is normally represented with P is equals to mass multiplied by first here. Let's just call it momentum. So that's the meaning of momentum. The body is in motion. So it is the product of mass and the velocity. So we have mass times velocity. The SI unit for mass is the kilogram. The SI unit for velocity is meter per second. So that's why we are referring to it as kilogram meter per second, of which in simples we can write it as So I'm just reminding you that again, when they ask you to state the SI unit of a given quantity, you don't state the symbols, you state it in words, kilogram, meter per second. That's when you get the answer correct. But if you state this as the SI unit, it's wrong. This is the symbol for the SI unit for momentum. Now, I want to ask a question. If, I know somebody's trying to sketch something. Now, if momentum is the product of mass and velocity, state 3 factors that affect momentum. Factors that affect momentum. Yes. John, any factor that affect momentum?
Mass of the object.
Mass of the object, very good. So the first right is the mass. Explain how the mass affects momentum. John, it's you who gave us the answer. So how does mass affect momentum?
If the mass of the object is high, the momentum of the body becomes great. And if the mass of the object is small, the momentum becomes less.
Very good. Very good. You have heard in most cases when a vehicle is moving, some people in upcountry areas, they say, you can accelerate the car, then you remove your foot on the accelerator, and then the car just continues moving. Watu wengi wanasema gari inatumia maji. A car cannot use water. At sasa hiyo gari unaona vile imekimya na inaenda mbio sana, sasa inatumia maji. Hapana. We only say the car has gained momentum. Yeah, so thank you, John. You have told us mass, you have explained how mass affects. Now, Abdullah, any other factor, number 2?
Velocity.
Right? Velocity. Explain to us how velocity affects momentum.
The higher the velocity, the higher the momentum of the body.
Very good. The higher the velocity, the higher the momentum. And then we have factor number 3. I can see a teacher, Mr. Ibrahim. Sorry. Amid Abdiaziz Ibrahim. Abdiaziz, any other factor that affects momentum? Fatma, can you try? Any other factor that will affect momentum apart from mass and velocity? There's a third one.
I think it's force.
You're saying force, eh? Okay, how does force affect momentum? Just try to explain to us how force will affect momentum. You are almost to the point. Okay, now Fatma told us that force will affect momentum, and I want you to understand that momentum is a vector quantity. A vector quantity has magnitude and has direction. So basing on that, we can see that change in direction can cause a change in momentum. That's factor number 3, the change in direction. So when direction changes, momentum also changes. This is because momentum is a vector quantity. It has magnitude and it has direction. And what is the direction of momentum? Momentum has direction in the direction of velocity. Those are the three factors that will affect momentum of a moving object. The first one, the mass. John was able to explain that. The second one, velocity. And the last one, change in direction. When force was mentioned, force can cause a change in direction. Therefore, change in direction changes momentum. Now, allow me to share you another short clip, which we'll talk about now, the Newton's second law of motion. Okay, that one has gone slightly ahead. So I want you to understand that when we talk about momentum, then we talk about factors affecting momentum. Momentum can change, and momentum can change per unit time. So the rate at which momentum will increase or decrease will depend on the external resultant force. Remember, Fatma told us that momentum can change if there is an external force. So this external force causing a change in momentum, it must be an unbalanced force. If it's a balanced force, then there can't be a change in momentum. So it must be an unbalanced force. It must be a resultant force. So it will cause a change in momentum. So the rate at which this momentum will change, whether to increase or decrease, will depend on the external resultant force and will act in the direction of that force. So the law is stated here, if you can put short note on it. The rate of change of momentum of a body is directly proportional to the resultant force acting on it. So I want you to include the word resultant force. Is directly proportional to the resultant force acting on it, and it takes place in the direction of the applied force.
Mr. Sifuna?
Yes.
Yes, Kasim Abdullah has a question.
Okay, ask.
I can't hear the video.
Oh, you're not? You're not seeing the video?
I'm seeing, but I can't hear it.
No, I've posted. I've posted for. Oh, you can't hear it, eh?
In the beginning, yeah.
Okay, let me just go back a bit.
Mathematical expression of Newton's second law of motion is
okay. Now let me start.
Experimental verification of Newton's second law of motion. Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the force acting on it and takes place in the direction of the applied force. The mathematical expression of Newton's second law of motion is F is proportional to mv minus mu by t. F is proportional to m into v minus u by t. F is proportional to ma, where m is the mass of the body, v is the final velocity of the body, u is the initial velocity of the body, and t is the time period in seconds.
Okay, so that is the Newton's second law of motion, where it said that when you are stating it, you remember to talk about proportional to the resultant force. So in between here, put the word resultant force.
Please unmute. You have muted yourself.
You have a question?
Yes, Abdimalik, do you have anything to say?
You are muted. I was telling you to unmute yourself.
The teacher.
Yes.
Okay, thank you.
Okay. What I was saying is we have come to the end of the lesson, and I want for you to remember the Newton's laws. To remember the Newton's laws of motion, think of an object which is at rest, then it starts moving. There must be an external force. So that external force is the one we have said, that which can change the state of rest or of uniform motion of a body. So when this object is in motion, it possesses what we call momentum. And when momentum starts changing, we are now talking about Newton's second law of motion. So what causes the change in momentum is the change in mass, the change in velocity, the change in direction. And the change in direction or the change in velocity is caused by an external resultant force. So up to that, I only encourage you that next time when we have the session, let's talk, let's interact, ask as many questions as you can, so as for you to perform well in this physics. Otherwise, I request to end there. You have been good students, and I believe we shall continue interacting. We shall continue having many sessions. Otherwise, thank you for that session.